Okay, good afternoon, everyone. My name's Bob Strodwick. I'm a Chief Technology Officer at ASOS.com, and I'm here today with a few of the architects and engineers from ASOS to talk to you about our replatforming program. And by way of introduction, I'm going to do a very quick summary of the story up to the point where we kick this program off. And because we want to leave you with as many actionable thoughts as possible, I'll outline my take on the 6 essential elements of landing a microservice platform. And these will be the themes of the next 60 minutes. But first, for those of you who've heard of microservices, who've heard of Azure, but maybe not too familiar with ASOS right now, here's our story. ASOS was launched in year 2000 to let people find and buy the products they saw on their favorite TV shows and movies. And the original idea came from a newspaper story where a TV station gets flooded with calls from people wanting to buy a lamp you can see in an episode of Friends, and you can still see it in the background, a central perk. And logically, this site was called As Seen on Screen. But quite shortly after that, it evolved into ASOS, a place where 20-somethings could buy trend-driven fashion, made by us, as well as other brands. And 17 years later, ASOS is a $2 billion a year organization, one of the largest online fashion retailers in the world, with a mission to be the #1 destination for 20-somethings worldwide. So, by way of sort of illustrating scale, our product catalog has 85,000 products. We're talking 14-odd million active customers, 8 million active native mobile users, 100 million page requests a day, that type of scale. And in terms of technology stack, our consumer-facing services, what we call the digital domain. Here we're primarily using Microsoft technology, so Azure Cloud Services, Azure Redis, SQL Azure, Azure Service Bus. That's what we're going to be talking about today. So the data domain, our data domain is primarily Microsoft 2, so Azure Data Factory, Azure Data Lake, so on. And in the business systems domain, we're more agnostic. So we have Oracle Retail, Dynamics AX, and we have MuleSoft EAI in the integration domain. Now, the background to this replatforming program was a decision made three and a half years ago that the software stack on which ASOS had built its business that had reached the end of its natural life and needed to be replaced. So at this point, we were $1.2 billion organization, something like that. So it was crucial. While it was crucial that we upgrade our capabilities, it's equally crucial that we do it without disrupting consumer experience. So pretty soon after that decision, we'd made a few big calls to go microservice, to go Azure PaaS, and this talk today is primarily what we did to land those things. Now the program launched formally in the final quarter of 2014, around about a year after that decision to replace everything was made, and we completed its first major phase in time for Black Friday last year, 2016. Now, sort of getting to the heart of the matter, what are the essential elements for landing a microservice platform? Well, one is we gained a little experience of developing for the cloud before we launched replatforming proper. Most significantly in our identity services, and we hired in architectural experience of designing software for the cloud. People who understood the implication of the greater degree of a transitory failure and all that. So one was about experience. We made two, we tried to take a principled approach to technology selection. We made a few big calls on the Azure PaaS model, and we stuck to them through the local difficulties of features that don't quite work how you imagine that they do, and those things that come with working in an application environment in which you don't have a lot of experience. So the second part was, I guess, about keeping your nerve. We tried to be thoughtful and pragmatic in our choices for Black Friday, primarily in the way that we tried to recognize our immaturity in problem triage and resolution in the cloud under duress, when it's Black Friday and you're really under pressure. And we did that by creating the simplest possible application implementation, the simplest possible geo-distribution model, and introducing a much improved monitoring and alerting capability to give us the insight we needed to what was going on. We built a really deep relationship, partnership with the Azure CAT team and Product Lab. We invested the time to make sure those guys understood what we were proposing to implement and gave them a seat at the table so they could influence our architecture, influence our implementation. Now, Dave Green is going to take you through all of the above, as well as talking in some detail about the actual architecture, about what we built. 5, we recognized that the promise of the microservice architecture of autonomous teams working on independently deployable units of capability, that doesn't come for free, that it's achieved through the hard yards of effective management of the emergent design process, and often using ways of working that on the surface don't seem terribly agile. So we created a role, a principal software engineer role, specifically to oil the wheels of team interaction and accelerate the point at which those teams could work independently. So we have Owen Ragg, the principal software engineer for replatforming here, and he's going to talk to you about how he did it. And lastly, we were able to bring to bear 3 years of heavy investment in automated build and deployment technology and processes to support the engineering and release effort that was required to land this new platform. And Ian Margetts is gonna major on that part of the story. So, without further ado, let me introduce you to the folks who are going to be presenting the detail today. We have Dave Green, Enterprise Architect for the Digital Domain. We have Owen Ragg, Principal Software Engineer for Core Commerce. We have Ian Margetts, Platform Lead DevOps. And now I'm going to pass over to Dave Green to take you through the first detail section.
Hi everyone, my name's Dave Green. I'm one of the senior architects at ASOS, and as Bob mentioned, I'm going to talk a little bit about the architecture we've landed, some of the approaches we took, and how some of the things we think we did that made it successful. So I'm not going to labour too long on the legacy architecture. I'm sure you guys have been through enough of these sessions or have been through personal experience to understand the sort of state of play that this would be in. ASOS had begun life about in early 2000, and back then there wasn't a lot of time to give thought to things like multiple languages, multiple currencies, or even clients that weren't a desktop-based web browser. Our code base had grown organically and rapidly to meet the needs of the business, and our architecture was fairly typical of an organization that had undergone such rapid growth. We had a monolithic application with all kinds of anti-patterns in it. We had horrible database integrations. And most tellingly, we actually had very little separation between our presentation and our logic. But we were finding increasingly that our customers were starting to demand different things from us. So increasingly, we were seeing a big uptake in traffic from outside of the UK. We were starting to see, amongst our core demographic, a huge uplift in the use of mobile devices. And we were just not able to support those very, very successfully. Because changing the monolith was difficult to do with confidence. We started looking around for alternative solutions, and we started layering on third-party solutions, so like dynamic proxies that would translate language on the fly, not quite as successful as some of the AI stuff we saw this morning, and even other proxies to reformat the HTML and make it mobile-friendly. So with inevitably, with this web of dependencies, the application performance started to slow. All of these dependencies started to affect our operational stability. Outages became more common. And as a pure play online retailer, the architecture which had taken us from nothing to over $1 billion was starting to get in the way. So we knew we needed to change. And we had some very clear ideas about what we wanted the next architecture to give us. Our customers were global, so we needed to be deployed globally, and we needed to be as close to our customers to ensure that they had fast, reliable access to the services that they needed. And if we're deploying globally, then internationalization needs to be baked in from the beginning. It can't just be layered on top. We need to be resilient, and we need to be able to scale. And scale for us doesn't just mean like scaling the runtime. This is about scaling your development teams as well, the ability to be able to work on multiple features in parallel. And we needed to be future-proof. We never wanted to be in the situation again as we were with mobile devices where we couldn't actively support a new or emerging platform or device. So all of this drew us to the conclusion that a cloud-based microservice application architecture was the best bet for the future. And as we looked at the design goals and the state of our current legacy estate, we realized that we're not going to be able to lift and shift this up into the cloud. This is going to be a re-engineering and a rebuild. So how did we go about that? Well, one of the things that kept us on the straight and narrow was a set of principles that we agreed fairly early on and, for the most part, managed to keep to. This allowed us to accelerate some of the decision-making processes and ensure that we were focused on achieving the design goals. So as Bob's mentioned, as retailers, we don't really think there's much value in running your own servers or managing your infrastructure. We think that the value comes from the code that you deploy on top of that and the experiences you create on top of that foundation. So to that end, ASOS will always prefer a platform as a service or a software as a service solution over running its own infrastructure. And only if we can't find a suitable, mature solution in that space will we consider running our own. We believe that there's an overhead in understanding and maintaining technology. So we seek to minimize the amount of diversity in the estate. That doesn't mean we're not going to use the right tool for the right job. But for example, we only want to look after one flavor of relational database. Same for programming frameworks or caching technology. It's not that we prefer a deep knowledge of a finite set of tools over a broad knowledge of a lot of them. And only if we can't meet them out of that set will we consider alternatives. Now, failure in the cloud, it looks a little bit different to failure on-premise. When you're deployed to multiple different cloud regions and consuming multiple different services, there's a vast number of combinations of things that can go wrong. So, for example, as Azure's shuffling around resources, you may find that you get blips in performance or even micro outages of a service that you're consuming. So your code needs to be resilient enough to back off and retry, or even look to see if that function is available in a different cloud region. And we knew that we needed to be able to walk before we could run. So our operations team was used to managing code deployed to a single data center that when it went wrong, it tended to go catastrophically wrong. That was fairly infrequent, but they knew how to manage that. We were moving to an environment where we knew we'd have multiple data centers, multiple different performance environments, and we expected transitory issues. So to that end, we decided to simplify the operational estate as much as possible. Now that we've gained some maturity in this, and the engineering teams are taking on more and more of the operational responsibility, we're finding that we're able to push back on this model and push these barriers back. But it doesn't matter how simple your estate is, if you haven't got the telemetry, if you're not monitoring everything, you're flying blind and you just aren't understanding what's going on. We also knew that we couldn't boil the ocean and tackle everything at once, so we agreed a series of phases and scopes up front, and Owen's going to talk you through in detail how we manage those. But at a high level, for the first phase, we decided we were going to lift all of the customer experience and the services required to support that, everything up to capturing an order, getting it ready to ship down to the warehouse for shipping. The one exception to that was our payments piece, which we decided to keep on-premise. At the time, we just didn't feel that we had the maturity to operate in the cloud and push our credit card details and various other pieces up into the cloud. Which is something we're now actively working on as we've gained that maturity. But for the phase one, we decided not to do that. And finally, we were fanatical about making sure that each of these services had clearly defined boundaries, separation of concerns. We never wanted to find ourselves in the dependency hell that the previous architecture had constrained us to. And it's worth mentioning at this point that ASOS didn't want to land this as a big waterfall project. The company wanted an architecture that enabled agile ways of working, and it intended to deliver it in that manner. So we didn't target a big upfront design phase. We did just enough high-level design at the front to identify the major components, the high-level communication that was required between them. And that enabled us to be able to scope out and plan our teams. There was an agreed order to which we went about this, but the design was emergent throughout the life of the program. So what did we actually build? Well, the architecture is designed to be consumed from the ground up by multiple channels. We prefer to expose our business and data through RESTful APIs, and we use lightweight events to broadcast. For our compute tier, we use cloud services for the moment. It gives us a good level of abstraction and isolation, but it can be a bit wasteful from a service density perspective. One of the interesting things about cloud services is there's relatively little flexibility in the way that you can configure and set up these things. You can choose how many instances you want and how big you want them, but that's about it. When you compare that to some of the next-gen PaaS offerings and compute offerings from Microsoft, with its myriad of options and configuration choices, in hindsight, we actually think that some of this enforced constraints around simplicity, whether that was a contributor to our success in getting into the cloud successfully. Each service manages its own state and data. Our data store, our relational data store of choice is Azure DB or Azure SQL. For NoSQL loads, we do have a few instances of IaaS where we're running MongoDB. At the time, there wasn't really a mature PaaS option for NoSQL. Now that DocumentDB, or Cosmos DB, it's now been rebranded, is becoming more and more viable. We're looking at a migration path for that. And depending on the use case, the services talk to each other either synchronously over REST or asynchronously using Service Bus. Each one of the services is integrated into our centralized monitoring and alerting platform. Again, this is one of those occasions where the PaaS offering from Microsoft wasn't quite mature enough at the time, so we had to roll our own. So we're using a combination of Elasticsearch and Kibana to give us our operational dashboards, our alerting capability, and a log repository for forensic mining and data mining after the event. Looking forward, Microsoft's operational management suite, App Insights, these are all things we're considering to moving forward. And finally, every service exposes a health check API, which is consumed by Azure Traffic Manager, and this lets it determine whether or not it's safe to route traffic to or not. And the whole thing is load balanced out of the box by Azure for us. So if we zoom out a little bit, and I'm not sure I expect you to be able to read that, you can see the rest of the estate. Each of the blue boxes represents one of the logical services, which are in turn made up of the microservices that we looked at. In there, but Akamai is one of our key parts of our architecture. Akamai is a third-party content delivery network. It provides us the capabilities to be able to edge data on cache data on the edge, and that allows us to offload workloads from the services and provide a faster customer experience. It also gives us some additional security features, such as bot detection. All of the customer traffic flows through Akamai, whether it originates from a native app or from the web client. And it's tightly integrated into Azure Traffic Manager to route that traffic to the most appropriate cloud service. So it's worth saying, as of Black Friday 2016, ASOS was in 6 cloud regions, but not all the regions were equal for us. We were primarily in the paired data centers in EU North and EU West. Because they were paired, we were easily able to replicate data between each of them for HA and DR functionality. And because they're in a paired network, Microsoft, during its upgrade and maintenance cycles, ensures that at least one of those regions is always available. Now, we did realize that this left us vulnerable to a European-wide outage, but we felt it was worth the risk, and following the principle of simplifying the operational estate, we decided to focus on keeping most of the processing within these regions. But we did want to make sure that our Australian and US customers were getting the best possible experience, so we identified the services for which latency was critical, and we deployed those to the US Central and Asia Pacific regions, which resulted in our identity and internal search services being deployed globally. It's worth mentioning it's not just bespoke code that we deployed to Azure. We've also got off-the-shelf functionality. So our content management system is Sitecore, which is an off-the-shelf package running in VMs in Azure. We created a new instance of the latest version as part of the reprogramming platform and migrated from on-prem feature by feature. We still do have a dependency down on the on-premise data center because we hadn't yet managed to migrate away for payments and order processing. These are all pieces of work that we're currently focusing on at the moment. And ASOS has the intention within the next couple of years to be data centerless and entirely within Azure. But to get data back to the mothership, we use a configured express route. So I've talked very briefly about what we built, but I'd like to just touch on some of the things we did to make that a success. So just for context, Black Friday for ASOS is one of its key trading events. For those few days, we expect to see normally more than double the usual traffic. And typically, in the Black Friday weekend, we'll take over 10% of our annual revenue. So making sure that the new stack was ready was a big deal for us. So we created a partnership with the customer advisory team, the Azure customer advisory team. If you're not familiar with this team, this is the team that Microsoft pays to make sure that people using that stack have a successful experience. They're not really interested in the latest and greatest versions. They're only really interested in battle-hardened production systems that actually work. They're a great bunch of guys. They work under a chap called Mark Souza in Jason Zander's crew. If you get the opportunity to work with them, I wholeheartedly recommend it. But what they brought to the table was the experience of hyperscale and the things like, so they have people in their team who've worked for Skype for Business and various other things that operate at that scale. Partnering with them, we went through architectural reviews and code reviews, and this, much like doing a pair programming exercise, forced us to explain and articulate to them how we would deal with every operational circumstances. And this piece of work revealed a number of gaps in our armory, which proved invaluable. So it was this self-diagnosis that forced us to double down on our efforts on the monitoring and alerting platform. We would do things like run full operational load tests on the system and then knock out a data tier or knock out a compute tier and see would the solution survive and would we understand what would happening. Because of our focus on designing for failure, usually we found that the solution was resilient enough to bounce back, but quite often we realized we hadn't logged nearly enough to actually understand what on earth had gone on in the process. So we had to go back round and tweak the logging and make sure that we were capturing enough information. Owen's going to touch on this in more detail, but the ability to roll out to real production and touch customers in a small percentage was vital to us. Getting that out there and engaging in real production testing gave us the insight to understand how the load operated really in the wild, and that allowed us to get a great deal of confidence so we could roll out wider. And finally, we were very fortunate in that our company was willing to understand and invest in the platform and understand how important it was for its future. So they invested over £6 million worth of promotional activity to drive an artificial peak before Black Friday so that we could do proper production stress testing. So this wasn't normal commercial activity. This was an investment in making sure that the kit actually worked coming into the peak season. So I'm going to hand you over to Owen Ragg now, who is one of our principal software engineers, and he's one of the guys who stops me getting all ivory tower. So he's going to talk you through the joys of trying to make 40 different software engineering teams land a project of this scale.
Thank you, Dave. Hi, I'm Owen, one of the principal software engineers at ASOS. As Dave mentioned, I'm talk about how we landed this from an engineering point of view. Right. The change was massive, basically. It involved our entire buying journey. So we rebuilt roughly 30 applications. So we're talking mobile applications, RESTful APIs, web apps, sort of data stores, and all this we moved from on-prem to Azure. And this also included, we had to rebuild our entire monitoring and alerting stack and move this to the cloud. In addition to the engineering activity being spread across 30 teams, each of whom is sort of responsible for the software from cradle to grave, we also had to involve all the operational teams, such as security, app support, etc. Just a brief time to mention the diagram here. This shows how we're sort of structured organisationally. We sort of structure ourselves into platforms, and each platform is responsible for a capability. So think order processing, bag, checkout. And each platform consists of roughly 1 to 3 platform development teams, depending on their scale. And obviously, one of the key things we need to address is that basically software engineers and teams are generally quite rubbish at talking to each other. So we would have absolutely failed dead in the water unless we actually had people who were here to sort of steer the communication and make sure things didn't get blocked and we just stopped. Sorry. And one of the other key challenges was, given the size of this, there's a huge number of dependencies we had to manage. Sort of dependencies I'm talking are about like APIs and message definitions. So we had to actually get in a place where we understood these quickly and enable us to work, teams to work autonomously and independently of each other. Underlying this, everything, quality is massively important. So in the last few years, we at ASOS have spent a lot of money and time investing in our engineering quality. So we have a software craftsmanship program, which every engineer goes through, and this is to learn things such as solid, TDD, etc. In addition to this, as Bob mentioned, we also created a principal software engineer role, but the role I do, plus numerous others. This is not just saying I stare at code all day. A big part of my role is making sure teams actually communicate to each other, they're clear on how designs work, and have correct CI/CD in place. And finally, another key thing we have to figure is how we rolled this out. The key driver here was to avoid doing a big bang release and having a massive site outage, which would impact our customers. Similar to Dave, we sort of had a number of principles we tried to adhere to throughout the whole process. So as Bob and Dave both mentioned, we wanted the teams to be autonomous as possible. So we didn't have a massive sort of waterfall type project. As Bob said, this didn't magically happen, and we had to do sort of several horrible-ish things up front to enable the teams to be independent and move forward. In addition to this, I've already touched on dependency management. We had to be very clear on all the dependencies and how we managed these and who depended on who. And obviously, we had all these independent teams delivering their bits of software. But the thing we had to also keep an eye on was, how did this work at sort of end-to-end ASOS.com level? Otherwise, we had all these brilliant little services which didn't actually work together as a whole. And also, one of the big things for ASOS is the customer is first. So in everything we built, we had to figure out how we were resilient, cope with transitory errors, how we rolled it out. So if customers were mid-session, what would we do with them? Would we lose their basket, or would they be able to continue buying? Okay, so autonomy. We could have defaulted back into waterfall mode, produced a massive MS project plan, but this would have been sort of against all the principles we're trying to work with, driving the teams to be autonomous. Obviously, we did have a massive MS project plan, but that's to keep sort of program manager types happy. Earlier, Bob talked about hard yards. This is the decisions we made, which weren't seen as particularly agile to help us move forward. And once the teams got to a place where the boundaries are understood of their various services, they'd actually be able to move forward quicker and more independently. So one of the ways we achieved this was initially we had a weekly 4-hour deep dive session where basically you had 30 people together in a room, so it's pretty horrendous. And the sole aim with this, everyone understood the dependencies, all the moving parts. And the key part of this was to make sure decisions were not made in silos. So everyone knew what decisions were happening, so everyone was on the same page. Over time, these meetings sort of decreased in time, and they ended up being sort of 30-minute scrum type meetings at the end. So in addition to these deep dive meetings, we spent countless hours with the architects and engineering teams mapping out the sort of different components involved in the deployment and the order of these and all the different dependencies. So this highlighted a couple of key things for us, that different sort of transition states for us in production. And that helped drive our sort of performance and functional regression test plans to ensure we didn't break the production site. We revisited this many times based on plans changing over the course of the project. As everyone here will know, the key to success is to integrate early. So we made sure teams were very clear on the contracts were defined as one of the very first things they did. And then we put a stubbing strategy in place. So we utilised Get Sandbox so the teams could independently create their own stubs and manage them, and they could develop before other teams had actually completed their work. But we also encouraged the teams to integrate very early, so before they were, as soon as the service was semi-consumable, we'd get them to integrate just to see what happened. So the diagram on the side here is of our bag service, which is one of our key sort of customer services. It's basically used in the browse journey, in the checkout journey. It stores the state of a customer's order effectively. As you can see, this has many dependencies. So it depends on about 7 different services, and about a number of things actually depend on it. So as previously mentioned, we could have waited till all the dependencies were sort of delivered and then actually develop the bag service, but that would have meant the project would probably still be delivering now. So hence why we went sort of integrate early and use stubs. Mostly what I've just covered could be described as shortening the lines of communication. So one of the key things I learned from this was you had to jump on any communication problems as quickly as possible. So simple things as 2 teams misunderstanding a contract definition. Most development teams would spend weeks arguing about it, but that had sort of doomed us to failure. So so one of my key responsibilities is to make sure I have these contract conversations with the teams to help them move forward where they sort of disagreements with each other. Okay, Dave touched on this earlier, how we actually did deployment. So we needed to break down the deliverables into a number of chunks, just so A, you could keep in your brain, and B, it was actually achievable. So we imaginally called these M1 to M5, just to break down the problems. And the order of delivery is not random. So, for instance, the first 2, M1 and M2, all about releasing the services and APIs to production, which then the clients can consume to rebuild the checkout and the buying journey. This had various advantages for us, so we actually carried out quite a lot of production performance testing and functional testing before anybody even consumed any of these services. After that, the next 3 releases were releasing the 3 clients, so again, the order's not random. So initially, M3 was releasing the Android client, and M4 iOS, and finally the web app. The order matters because Android is our lowest volume client. So we basically put that out there, not many users, we can find any edge case bugs, fix them, move forward. iOS, a bit more volume, find some performance bugs, fix them, move forward. Then finally the web app. And even within each one of these releases, we phased the rollout. So we didn't just go big bang Android, big bang iOS. We released store by store to enable us to go 10% to customers, 15% to actually get key learnings from doing that. So clearly, ensuring quality of what we produced from both functional and non-functional point of view was absolutely key for us, and we needed to understand where we were. As mentioned, the teams basically cared about their sort of vertical slices, but clearly that left a massive hole for us. That was, who cares about the end-to-end journey? Who does the sort of end-to-end testing from a perf point of view, a functional point of view? So to solve this, we established a central QA function, and their responsibility was to build a lightweight sort of end-to-end test pack, which did both functional and performance testing, and continuously execute this so we'd know exactly what state we're in at all times. To support this, they obviously triage these defects and actually work closely with the teams, so the teams understand the priorities and how to reproduce them. So what's become clear, this team works so well for us, they've actually now become a permanent fixture at ASOS, and they actually now look after our path to live. So another massively important thing was to have a quick, repeatable process for deployment in place, so CI/CD. So Ian's going to talk about that following me in more detail. The major benefit for us was understanding the quality of what we had in place. So we invested time building a good set of automated tests. So we knew across the stack what state we're in at all points. Additionally, the ability to sort of easily and repeatably deploy builds to many and multiple environments was utterly key for us. Finally, I mentioned that the customer is key at ASOS. And to do this, in terms of rollout, we had to actually plan our rollout in quite a lot of detail. Otherwise, we would have quickly failed and died if the teams just deployed their bits at sort of randomly at will. So one of the key parts of that was figuring out all the different feature switches we needed so we could enable teams to go live with their stuff, but in an off state. As also mentioned, one of the other key things we wanted to do was deploy not in a big bang state and not affect customers mid-session. So to do that, we implemented session cookies, which Akamai set based on configuration. So in its default state, that would mean no one would see the new functionality. But we could enable it store by store or by group of IP addresses. And then any new customers would pick up the new session cookie, see the new functionality. And then anybody who's mid-session would still see the old functionality till their session expired. So that enabled us to roll it out. That also had several benefits for us. So we effectively carried out a large-scale beta test internally in our office by getting Akamai to set that session cookie to true for everyone in IP address range in our building. Again, sort of minimizing customer impact in terms of bag. So we mentioned coding for failure. So we spent a lot of time with the CAT team, as Dave mentioned, and ourselves, figuring out what happens when stuff starts to wobble in the cloud. So we used heavy use of the sort of transient error handling block. We also looked at what happens if some service wasn't available. So for instance, we've put the bag service here, has a cache in front of product, so it can cache the data for 15 minutes, and at that point it won't be too stale for us. And also say, we do something quite strange. We reserve stock when you add to bag, and that normally is a synchronous call on this diagram. But so the customer could keep going, if that was sort of under duress, the SOC service, we would actually enable an asynchronous mode that basically gets put on the queue, the message, and processed later. So we did everything possible to enable sort of the customer journey to continue. In summary, the key learnings for me were, what we did was agile at scale, and everything to help us succeed was try and help enable the teams to be autonomous as possible to start with. And that proved painful, and there was lots of complaints about it. And also throughout, ensure communications were good. Do not let teams go into their silos, otherwise you will die. So thank you for your time. Next, I'm going to hand over to Ian, who's going to talk about our DevOps capability.
Thank you, Owen. Hi, my name's Ian Margetts. I'm the platform lead for ALM at ASOS. DevOps is a long-term transformation for many organisations. So what I'm going to talk about today is what we achieved in DevOps for the 4 years leading up to 2016, what we learned, and how we needed to adapt to support the re-architecture programme that the guys have just been talking about. Pre-2011, we were largely manual. We only had a few teams way back then. Everything we did was manual deployment, manual provisioning. In 2012, we'd grown to about 6 teams. We needed to start looking differently at this. So we took a step back. And this was our first real step in our DevOps journey, the first sort of understanding we needed to change. And we looked at 2 key areas. The first of those was a lack of repeatable automated deployment process. The second was around our test environments and the lack of consistency across those. So, to address the former, we looked at an in-house custom solution. At the time, there wasn't much out there in the market in terms of tools, so we decided to write this stuff ourselves. What it was do was actually deploy to dev and test in a repeatable, automated way and gain consistency across all the teams. And that worked really well for us going for our dev and test environments. When we got to production, however, we still fell back to a central DevOps model. Those guys would repackage it, and they would then take it out to production for us, so the teams didn't have that production access. This was all backed by a central DevOps ALM team to help drive this through. Now, what these guys were responsible for was driving the change through all the teams, ensuring consistency, but most importantly, supporting them as we needed to develop new features or we needed to onboard new teams. Then these guys were responsible for making sure that continued to happen and was consistent across that approach. Now, this was a significant first step for us in terms of our DevOps journey for 3 reasons. The first one it really embedded the concept of a repeatable automated deployment with teams for the first time. They'd started that cultural journey. They really started to understand that it was important to invest in path to live activities right back at the start of their cycle, which I hadn't really done before. And thirdly, and probably most importantly, it started to set the precedent with the business that they needed to invest heavily, and it was beneficial to invest heavily in both the plumbing, tools, and competency to give us that real benefit of all the work we were doing. And this got us a long way. You know, we went from about 12 releases a year to 300 releases a year. So it made us a significant step forward in what we were able to achieve. However, we understood the central model was actually quite limited. It was important at the start. It gave us that consistency. It gave us the stick to drive the teams with to make sure they started doing the right thing. However, we realised that it wouldn't scale, so we had to review that situation. To really realise our potential, what we needed to do was create a much more devolved DevOps model. So what do we do to align that to the work we were doing? From 2012 to 2015, quite a lot changed for us. There was 3 key factors. The first of which was the re-architecture of the code base, which Dave and Owen have been talking about at length up to now. However, I think it's important to talk about this from a DevOps perspective. As we were starting to realise the changes that were being made by the teams, we now have the technical underpinning to really make some changes in the way we thought about things. The first one was obviously we could start to think about feature-based releases. Up to now, we thought very much only about big project-based 3-6-month projects with big landing at the end of it. Now we can start to think about small changes. Secondly, we were no longer dependent on each other. As Dave and Owen said, we went through quite a lot of pains to make sure that we were actually genuinely independent across those platforms, so they could now release at will whenever they felt they needed to. And what this meant was that regular release became a reality for our teams. For the first time, they could think differently. And in fact, there's little benefit in having a microservice-based architecture if you don't have this capability. The last thing on this area is to talk about Azure. So Azure was huge for us. Up to now, we'd had to craft dev and test environments to represent kind of our archaic structure. Now, through Azure, we now could think really differently about this. We didn't have the same constraints that we had before, and that could make us think quite differently. Secondly was the emergence of the platforms. Now again, Owen touched on these earlier on. As we started to go through the re-architecture program, we established a mechanism by which these teams could look after this code base once we delivered it into production. What this meant was that the teams now had a long-term interest in the health of the platform they'd helped deliver. They had more responsibility in both dev and production. And they understood the infrastructure that they were actually deploying onto much more than they did before, and they could release regularly to it. This was all backed up by the fact that we actually made them directly responsible for support as well as development. So it was critical for them to have the right data and be able to act on any problems really, really quickly. The last key driver for us was release demand, and this is a really critical one. ASOS is customer obsessed. It's one of the key things which differentiates us from the rest of our competitors. We were now unlocking that release potential through the re-architecture, but what we needed to do was remove the impediments from the teams to enable them to be able to drive through more. And the most important thing we saw is that was going to block that was the central deployment model. So, what do we do about it? To support the business, we need to make some key changes. To let go of some of the central tenets that we'd held up to now. What does it actually mean? Well, we needed to empower the teams, whether that would be in creating their own pipelines, in deploying software, in provisioning, in hooking up to monitoring solutions. We need to put that power into the hands of the teams and away from this central team. We need to improve the team competency. Many teams say they can do DevOps in the same way they say they can do Agile, Well, not of them didn't actually understood what that mean. So we need to actually put some support in place to help drive them to the point where they actually genuinely did understand it. We need to put support close to the teams. So we couldn't just be a competency. As we were going through this re-architecture program, we had almost some hard deadlines we had to hit. So we had to support these teams in actually migrating them through and getting their pipelines into a good place. And we had to support cloud development. Now, by now, a lot of our teams were already in the cloud, but we still had teams going into it on a daily basis. And obviously, as new features came out, we needed to support them, and this was a key DevOps role. So we now had our goals. What do we do about it? Again, 3 things. The first one was tooling. We picked VSTS, TeamCity, and Octopus as our stack of choice. Tooling isn't the answer to what is actually a people and practices problem. However, what it did for ASOS was give us a reboot of DevOps. By adopting best-of-breed tooling, we immediately brought the teams on board, and so as we wanted to drive out the future changes beyond that, we then had a willing audience who were willing to work with us and actually drive you through more effectively. It enabled the teams to start thinking about development rather than deployment for the first time. They didn't have to go through these long deployment cycles, and actually that made them more productive. And through CI/CD, for the first time, we'd actually start to get faster feedback cycles. We also rolled out the competency. Now, Dave and Owen already mentioned this. In fact, Owen is one of the key members of the competency. We now had dedicated staff whose job it was to help those teams improve. They did that through coaching, mentoring, workshops at both the individual and the team level. And their role was to really make sure that we didn't compromise on the quality of our code as we strove to meet these deadlines. They would also make sure that any competency issues were raised up and could be handled at an enterprise level. The final thing we did was introduce the concept of the platform engineer. So this was to move our DevOps skills closer to the team. So we created 2 functions. One was the devolved DevOps. And their role is to sit and work with the teams on a daily basis to actually help implement pipelines and make the things happen, but also as a competency to bring those teams up through metrics-based conversations. However, we also thought the central team was still a key role for what we were trying to achieve at ASOS. We needed a central function that would be the home of the competency, look after the core infrastructure, but also handle those enterprise concerns and make sure that we could scale. So to bring this to life a little bit, I'm going to talk about the orders platform, which is one of our critical platforms that we went through the re-architecture. So pre-M2, these teams were entirely on-premise. All their deployments had gone through a centralized DevOps model. They had no control over their infrastructure whatsoever. Their dev and test environments did not represent live in any way, shape, or form. And their releases, therefore, were quite infrequent, very painful at times, and we had quite a lot of rollbacks. Throughout the re-architecture program, we supported them. The key things we did were actually made them responsible for the DevOps. We gave the power to them. So by the end of the process, they were now partially in Azure. Dave mentioned that earlier on they didn't actually quite make it all the way up, but we now had elements in Azure and on-prem. But regardless of where they were, they now had full control of both of those. Through pipelines, they could now deploy to both of those equally, and we had good logging and monitoring in place, so they could understand the problems regardless of where they were. We put the competency close to them. So we had people like Owen and my platform engineers actually working with these guys on a day-to-day basis to ensure they were successful. And through the CI/CD pipeline and improved test environments, we made sure that they had a higher confidence in what they were delivering. So as they were going through that pipeline, they could trust the results. So when they went to production, we got a much better success rate. The result of this was that by the end of the program, these teams were releasing daily, very high success rates, very few issues, and very good monitoring in place. So by the time they actually found a problem, they could resolve it very quickly. More generally, we saw the same kind of results across all the teams. We saw teams taking ownership. They actively wanted to take on the pipeline themselves. They actively wanted to develop these things themselves. They were actually getting involved in resolving issues and really understanding the core problems, which before they hadn't been doing. There was a massive reduction in release effort. The vast majority of our increases in releases were down to this. Through the few years leading up to 2016, we didn't recruit any more central DevOps staff or any more central release management staff. Yet our releases increased 4-fold in that period. And we were seeing resolution of issues much more quickly. So pipelines, through pipelines, automated environments and tests, we were seeing much quicker identification of issues and resolution of those. And this is especially true where teams were purely in Azure. There, they could absolutely create environments of exactly production-like, and therefore identify issues or make sure they didn't have them in the first place. All of this was based through kind of metrics-based discussions. So up to now, we'd only looked at releases as kind of key metric, but now we started to think about the things that were much more important. And teams were using this to drive through and make sure they were actually getting the right things handled very early on. Since Black Friday, we've continued to roll that out, and we're now got a full continuous improvement program with those teams to really get them into a good place. So the punchline to all of this really, and line back to our Black Friday objectives, were that actually we got all of the components released prior to Black Friday successfully. And collectively, we all believe that if we hadn't done this shift, there's no way we would have actually achieved these goals. So, bring it all together. In the 5 years since we started a DevOps program, we've actually managed to increase releases 600-fold within the organization. It's easy to see this getting to 10,000 a year in the next couple of years if we continue to keep driving through the culture of continuous improvement with the teams. So that's kind of me done for the day, except for the last thing I'd like to say, really. ASOS has had a considerable journey over the last 5 years, both in terms of business and technology, culminating in where we got to with our Black Friday last year. Through sustained focus in DevOps, we've managed to adapt to create a scalable model that actually really reacts to the needs of our business and should see us going forward for many years to come. I'd like to thank you for your time today. I'm going to hand back to Bob now, who's going to talk about some of the really key stats as to why we thought this was so successful.
So, thanks, Ian. So, tying all this up then, here's some numbers from Black Friday, which I guess was the first sort of big reputational test of the new platform. I guess in summary, in the end, we had a sea of most evers. The most ever sales in a day by miles. The most sales in an hour ever. Over 500,000 orders. That's the most orders in a day ever. We peaked at 33 orders a second, and that's the most orders per second ever. And the new platform didn't break sweat. The product service maxed at around 3,000 requests a second, and we served 176 million requests over the service tier during the course of the day of Black Friday, at an average response time of 48 milliseconds. So it was a great day, really. Yeah, there's plenty of stories on that day, but none of them are for sharing today. So I hope that you enjoyed that and found some of the points we tried to make informative. I think we have about 5 or 10 minutes. So if there were a question or two, we'd be happy to take them.
We have a question about how you manage the workload for the team. So I don't know if this is for Ian or for you. So the teams, you tried to devolve their responsibilities so that they were taking more of the operational. They're responsible for the production code as well as new development. Is that right?
That's right, yeah.
Okay, so if there were issues in production, there was no separate operations team that was monitoring. It was the team that wrote the code is responsible for.
That's great. We still have a central sort of first-line support, and we still have central incident management because things like you want to have a coordinated approach to things like telling the warehouse. So, for example, if there were a problem with the order processing services and no orders are going to go to the warehouse for N period of time, you need to tell the warehouse to do something with the shift. So we have that type of sort of comms part, but the support has become really the bit which is looking at the software estate, figuring out which service it is and alerting somebody, and then it falls to that platform team to do the appropriate problem triage and resolution.
Okay, so then how do you manage the capacity of each of the teams? I think you mentioned there's 40 plus teams that you're using. does one team own a particular service in perpetuity? So
Yeah,
if there's ever
correct,
any
yeah.
issues with that one, they deal with it. But what if they have current other things on their plate? How do you manage that workload?
Well, I guess it's a good question. So if you take, say, we have most of the people are based in London. We have a satellite office in Birmingham, 4 software engineering teams, and they represent payment. So they are the payment platform, and their role in life is to make the most appropriate set of payment methods available for our consumers. So the platform lead's job with a product manager is to figure out things like what's the balance of resources going to go into developing Apple Pay versus the resources that are going to go into resilience versus the resources that are going to be looking at production issues and doing something about them. So the platform lead then, how we do it is quarterly, you go ask for money against a set of KPIs, and your job as the platform lead with the solution architect who's in your gang and the product manager is to basically set a case out for money for a period and balance those things out.
Okay, thanks.
No problem. Hey.
So when you got the releases like up to 1,200, are you getting it down to like even one bug fix granular, or how big are your releases because there's so many now?
Well, I guess the thing that we sort of saw, what you do, you create the capacity to manage risk. So when in the olden days when we did fewer releases, then it's not quite an apples for orange. It's not quite an apples for apples thing. What you're doing is you will see much smaller. We make 1,200 releases, but they're going to be much more granular because through the capacity to do daily releases, you allow software engineering team to atomize the changes going to production and manage the risk that way. So the real answer is it depends on what platform you're talking about, but the purpose of the DevOps capability is to create the capacity for teams to fix one big bug at a time if they want to.
Okay. You're making all these autonomous services, but the teams have to contract together.
Yeah, they do.
Okay. So is there not a shared domain model that they're using, or you're sharing data contracts, or who's driving that?
So in our world, how we've tried to manage it is through, you want the architects to own the separation of concerns. Their job is to draw the boxes and the contracts between them. And how we try to how we try to manage it is that an architect and a software engineer, principal software engineer, will be paired up. They man-mark each other. And what you'd expect the engineering team to bring to the party is much more of the sort of knowledge about, if we implement it like this, it's not going to perform. Or if we implement it like this, here's the implementation issues that are going to arise. So how we try to do it is to make sure that we can hire solution architects who think big box architecture, think about a logical separation of concerns, who are thinking about how those services meet the design goals, who are thinking about a first cut of the service contracts between those services, and then teamed up with an engineer man-marking them, then you let the design emerge. And when those issues come, and this is really where a principal software engineer like Owen or Scott Frampton will earn their corn, is those issues between two software engineering teams working out how a service contract works in real life. If those conversations are mediated, they can go on for yonks. The purpose of a principal software engineer is to make those conversations compact so that they get thrashed out there and then. You agree something, everybody moves on. But it takes a bunch of coordination. Coordinating that emergent design process is the difference between having it work and having it not work.
Thanks.
Hi.
What's your take on the, well, you've repeated time after time that you're a really user-centered company. for your customers.
Yeah.
And so what are some of your lesson learned regarding like UX and the conversation that is ongoing with the technical folks and the UX folks and the way it can drive vision and changes from time to time in the project?
I guess there's a couple of things. One is we try to have a really clean separation between the consumer channels and the underlying service tier. So we would expect, we're an organisation that's aimed at 20-somethings. We expect those 20-somethings to be in the early adopter end of the spectrum. So we wanted the ability through that clean separation of the service tier from the consumer channels to be able to innovate in conversational commerce and different ways of presenting our capability to the consumer. And I suppose too, in a way that by having that those set of autonomous platform teams, what you're sort of seeking to do, I suppose, is to create the autonomy to drive innovation in each one of those areas, sort of create the sort of drive for, you want the payment platform to feel like they have the capacity to be the best payment platform that they can be, and ditto with the other platforms.
So did they have the same structure of decision with the UX guy that you have in the software guys? That
Yeah,
they
that's
have
right.
Like
So,
a main solution UX and.
Yeah, so we have platform teams that cover web and native mobile applications, and again, those guys would have the mission for their platforms to be as good as they can be.
Cool, thanks.
No problem.
I'm back.
Hey.
We're in the middle of this, that's why I'm up here. Very early, when you're trying to be agile and you're having all these autonomous services,
Yeah.
was one service calling another service and that service returned dummy data, or you just mocked out the whole service altogether, or how did that come up when everybody's not done, not ready, but you got to call something?
One of the detail people want to do this one?
Thanks. So the first thing we did was make sure the contracts were 100% complete. And whether the team decided to use stubs for that then, which returned like a complete set of data, or they just focused within that contract, returning, say there was a customer, just the address bit first and the rest nulls. But the key thing for us to get the contract 100% complete, then sort of build out the data beneath it. And some teams decided to sort of put stub data in there, etc. Does that answer?
Yeah, you focused on the contract. You
Contract
said-
first,
okay.
then build out the data.
Okay, thank you.
Do you have instances where you have these different versions of the same microservice in
Yep.
your production?
Yep.
And how do you manage the versioning?
You can do that.
You can tell the supportive culture on show right now.
Change, but so typically breaking contracts is a new version. We would like that. If it's not going to impact the clients or the consumers internally, we wouldn't typically version increment. But this is again where we would feature switch in those things. So the consuming services would be, if it was a breaking contract, the consuming services would develop a feature switch to enable them to point to the right one in a phased manner and manage it in that way. Does that answer the question?
Yeah, we got to go. We're just getting the sign. So listen, thanks very much. Hope you enjoyed it and enjoyed the rest of the conference.
Thank you, guys.